So let's write a basic prompt to do paraphrasing. For example, paraphrase the following sentence using a diverse choice of words. So I'm just trying to build a paraphraser and see how well it performs. So this is the input sentence, and let's give something like paraphrase. So I'm expecting GPT-3 to paraphrase this sentence. So using this example, we'll understand the parameters on the right. First, let's run this and see. Okay, so it paraphrased as a group of frogs was once roaming around the forest in search of water. So minor paraphrase, the ones came here, etc. But nevertheless, not bad. So let's begin with the parameters that we have on the right. Let's start with maximum length. This maximum length defines how many tokens at maximum can be generated for our input. For example, here we have 100. Let's keep this as only 3. What happens is that our generation should stop at just 3 tokens. And let me click on regenerate. As you can see, we just stopped our generation at just 2 words. Now since we are at this junction, let's understand the relation between tokens and words. So you can go to beta.openai.com/tokenizer, where you can see a demo of how sentences or words can be converted into tokens. So simply put, a token is not necessarily a word. A word could be subdivided into multiple tokens. For example, let's give a simple sentence like John is awesome. So what happens is that John is awesome is exactly divided into 3 tokens. John is 1 token, is 1 token, and awesome is 1 token. So GPT-3 has created a tokenizer with all the vocabulary that it has got, and any word that we give is divided into tokens using the tokenizer and is shown here. But what happens is that John is awesome are commonly occurring words, so each word is tokenized into 1 token. But let's say if we just give something like Ramsri, we can see that Ramsri is divided into R is 1 single token, AMS is 1 single token, and RI is 1 single token. So essentially just the word Ramsri is divided into 3 tokens. So you can kind of assume that Ramsri is going to college. So right now we have almost 5 words here, but it came out to be 8 tokens. So for simplicity, understand that the token count is usually more than the word count, and each word could be subdivided into multiple tokens depending on the vocabulary that GPT-3 is trained on. So you can go ahead and read more about tokenizer and tokens, but that's essentially what it is. So coming back to our use case, although we gave maximum length as 3 tokens, it just generated 2 words because group could be subdivided into 2 tokens. So this 2 words could be 3 tokens in total. So simply put, even if you give, let's say, 100 as maximum length, it does not mean that we will generate 100 words in the output. GPT-3 generation will stop either if 100 tokens are reached, which could be less than 100 words, or if a stop sequence is reached, which could be, end of sentence token. For example, here if we are doing paraphrase, even though we can give this as 300 or 400 some maximum length, GPT-3 knows that it just needs to paraphrase this, and after this full stop, end of token is reached. That's why the generation is stopped. So let's rerun this again. If you want to just rerun, you can click on regenerate here, and you can just keep clicking on regenerate, and it will keep generating newer and newer generations. Now you understood what maximum length is, which is the maximum length of tokens that can be generated for your use case. If you have something simple like sentiment analysis where you need to generate just good or bad, etc., then you can just keep maximum length to 2 or 3 tokens itself. Now let's understand what this model parameter is. Primarily there are 4 important models that we need to know of: Text DaVinci, Curie, Babbage and Ada. Simply put, Text DaVinci 002 is the most powerful as well as the costliest model. Then Curie is slightly less powerful but cheaper, and similarly Babbage is less powerful and cheaper than Curie. But you can see the strengths of each model here. So you can give any complex intent and creative generation, summarization, search, etc. with DaVinci, and with Curie you can do some translation, classification, sentiment, etc. With Babbage mostly it's classification or search. Similarly with Ada you can do some keyword extraction, etc. So whenever you design a prompt, first I would advise you to design the prompt with Text DaVinci 002, and then later see if the same prompt can perform well with Text Curie 001 as well. If so, switch to Text Curie 001 to reduce the cost as well as the speed of execution. Now let's understand what this stop sequences parameter is. In order to understand stop sequence, let's modify this prompt a little bit. So I just modified the prompt like this. Below is a paraphraser to modify the sentence using a diverse choice of words. And you have one sentence and its paraphrased version. And as you can see, it is enclosed within triple hash. So ideally, it should generate the paraphrase sentence, then again generate a triple hash. So if you want to control the format, exact format that it proceeds with, and stop generation at the appropriate place, what you can do is you can give stop sequence as hash 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 or new line, or if you are using some specific word, for example you're doing chatbot and customer colon and chatbot colon, customer colon, chatbot colon. So whenever you generate chatbot output, again it will automatically generate customer colon, but you want to stop the generation there, so you can give the stop sequence here. Essentially you can give the stop sequence where you want the generation to stop, and then you can click on submit. So it will only generate the necessary text, and whenever it encounters the stop sequence, it will stop the generation there. You can see that it's a paraphrase that we got. The flu is characterized by a fever and a stuffy nose, a fever and nasal congestion. So nasal congestion is replaced with stuffy nose. That's good. Now let's get to the interesting parts of the parameters, that is temperature and top P. So simply put, temperature and top P, they control the randomness or creativity in the generation that we get. For example, if you just keep temperature to the maximum and top P to the maximum and just click on submit, as you can see, it is forced to be more creative. That's why you will get a diverse choice of words. And keeping temperature and top P to the maximum, it's ideal if you are generating open-ended response, for example just filling up some story, etc. But usually if you are doing something like paraphrasing or even summarization, etc., you want to use the words that have already come in to certain extent. So since these are like creativity parameters, you can perhaps keep them at 0.7 or 0.5 or something like that, because you don't want to be fully creative. You want to generate, but within certain constraints. So what OpenAI advises is mostly to keep one of these parameter constant at the highest and change the other. That means you can either keep temperature maximum and change top P, or you can keep top P maximum and change temperature. So you can kind of assume them as creativity dials, where you can dial them to the maximum for creativity or change them to the minimum to be more deterministic. That means if you keep temperature as 0, even though if you regenerate, let's say now the temperature is 0, every time you click regenerate, it will generate the same thing again and again, because now there is no creativity at all. You have dialed down that creativity or temperature parameter to 0. So no matter if you run again and again, it will generate the same sentence. But if you just keep it at the maximum, it is forced to be more creative. That's exactly what this is. Now in order to just give you more insight into temperature and top P, technically let's turn on the probabilities full spectrum and I'll show you what this is. So what happens is that every time when you're generating a word, the word is not random, but rather, for example, here stuffy or stuff. When the model is generating this word, there are many possibilities, and among those, stuff could be generated with 90% probability, and run could be generated with 2.55%, blogged could be generated with 1%. So at every step when you're generating a new word or token, there is a probability distribution that you can choose from, and that varies constantly depending on where you are in the generation. So at this point in the generation, stuff has 90% probability and stuffed is 5%, run is 2.5%, blocked is 1%. But of course we are choosing randomly. But what happens is that if you keep top P as 0.9, what this means is that at 90% itself you'll stop. So you'll only pick between stuff and stuffed. Then you include both stuff and stuffed if you keep this as 0.96, something like that. So as you decrease top P, you are only choosing from the top 93% probable words, and if you keep top P as 1, you are choosing randomly between 100% of the words that you get. So top P is essentially, among all the probable options, you are cutting off words if you are decreasing top P, that is only choosing from the top 90% probable words, etc. And temperature is something similar, where you are modifying the probability of the output tokens by dividing by this temperature parameter. So if you keep temperature parameter as 100, there is no change to the output probabilities. But if you just divide by any other number, let's say 0.87, what you are doing is you are increasing the likelihood of high probable words. So the generation will be less creative. So essentially temperature and top P are those, and for creative applications you keep them at maximum. If you want some deterministic application, then you keep them at 0 or 0.5, or if you're doing something in the middle like summarization, keyword extraction, probably 0.7, etc. Now the remaining parameters that you need to understand are frequency penalty and presence penalty. They simply mean how much you need to penalize the words that are already present so that they are not repeated. So if you increase the frequency penalty, then the model is less incentivized to use the same words, and presence penalty is similar, where as you increase the presence penalty, the model is more incentivized to talk about new topics. The only difference between frequency penalty and presence penalty is that frequency penalty takes into account how many times a certain word has occurred to penalize that. That is, it also takes into account the frequency of a word that has come already in the text, whereas presence penalty just counts whether that word has occurred once or not to determine the penalty. That's the only difference. Simply put, if your generation is using the same words every time and you want it to talk about new topics or don't want to use the same words that are already there, you just increase the frequency and presence penalty to some value that you're comfortable with experimentation. And just to understand best of simply means that whatever number that you keep, for example 3, GPT-3 will run this prompt 3 times and choose the output that has the highest likelihood, or it will return 3 different outputs if you just keep this as 3. But remember that almost this is directly multiplied to your cost and usage. So if you just give best of 3, it's almost like running this 3 times, so it will cost 3 times. But if you are doing something like paraphraser, etc., what you can do is give best of as 3. Now you'll have 3 different generations or alternative paraphrases. So it's almost like running 3 multiple runs simultaneously. And this inject start text and inject restart text, they are not necessary, because if we do programmatically like we are doing with Python, etc., it's just some text that needs to be added before running the generation, or some text that needs to be added after running the generation. I think you can just add them with text Python strings itself, so we don't need to use this. So that's essentially what these parameters are. Now before moving further, this is what we have been using so far, which is the complete mode, which is just completing the input prompt. But there is also insert mode and then there is edit mode. Let's just click on edit mode, and what this says is that you can give any input sentence. You can just give some instruction, for example, paraphrase this sentence. So basically you can just run in the instruct mode like this, and it will automatically generate, based on your instruction, some output. As you can see, was wandering around the around the forest in search of water. So even edit mode is quite useful in some cases. You can just fix the grammar, paraphrase this sentence, etc. So you can give some input text and give some instruction, and it will generate based on that input and instruction. And there is insert mode as well, where you can give some input, output, and in the middle you can ask it to insert. For example, you can say how to grow on Twitter to 100k followers, and give something like just start tweeting daily, then just insert, and maybe let's say 6th bullet point is celebrate 100k followers, and let's just give something here, 150 tokens. Yeah, let's click on submit. As you can see, GPT-3 will smartly insert, for example here bullet points, apply Twitter marketing strategies, follow popular Twitter accounts, use hashtags, share interesting content, something like this. So basically, even you can give a story, some starting and ending, and ask it to insert. That's what insert mode is. Hope you learned quite a bit about the parameters that we have here, etc. And I'll see you in the next section where we will see how we can build a paraphraser.